Okay guys, today we're going to be doing 13.5, so your packets should be on page 769. And today we're going to be learning about a third congruence theorem called the angle side angle congruence theorem. So we're going to be looking at triangles that have two angles and the included side congruent. That's why we have the side in the middle, because it has to be the side between the two angles. So let's actually prove this using constructions to start. So for problem 1, I am giving you a segment that has to be part of your triangle, segment AC, and then I'm giving you angle A and angle C. So we are going to construct this using angle A and angle C, and then obviously segment AC needs to be in the middle. So the way we're going to do this, we're going to start by constructing our starter line. And we're first going to construct segment AC. So I'm going to put a point and label it A. And then to copy the segment, I'm going to open my compass and then draw an arc on the line that I just drew to start. And label that C. So our first step was to copy segment AC. So I'm going to write that down. So our first step was to copy segment AC. Now, angle A has to be using this point A, so I'm going to need to copy that angle. And angle C is going to need to be using point C as the endpoint, so I'm going to copy that angle. So to copy both of my angles, I'm going to draw an arc that goes through angle A. I'm going to copy that arc using A as an endpoint. And then I'm going to measure the distance between the legs of angle A, and I'm going to draw an arc that matches that distance on the arc that I just drew. Now, I need to make sure that this lines up with angle C. So I'm going to do the exact same thing before I draw the point to angle C. So I'm going to draw an arc that goes through the legs and then do the same thing on endpoint C. And then I'm going to match the distance on angle C and draw a second arc through there. Oh, using this endpoint. Okay, so I have 2 points of intersection and everything should line up. So what we did next was we copied angle A and we copied angle C. And our last step is going to draw triangle ABC. So this tallest point is going to be my point B, and everything should have lined up so that it makes triangle ABC. So this point should go through all 3 points. And it does. So there's triangle ABC. So then look at your triangle and look at the person next to you and their triangle. And I want you guys right now to determine if they are congruent and why. So you should have got that yes, the triangles are congruent. Because everyone used the same side and the same angles. So because we all had this angle and this angle, and we had the side in between them, we can conclude that the triangles are congruent. That is called the angle-side-angle congruence theorem. So let's read what that says on the next page. So it says, the angle-side-angle congruence theorem states that if two angles and the included side of one triangle are congruent to the corresponding two angles and the included side of another triangle, then the triangles are congruent. So it has to be two angles and then the side in between those two angles. So it can't be two angles on any side, it has to be the side between the two angles. The included side is the side between two angles of a triangle. So you must have both. So let's look at problem 2. Now that we know the angle-side-angle congruence theorem, we are going to use that to determine if triangle ABC is congruent to triangle DEF. So let's just look at these two triangles to start. So first of all, talk with the people in your groups. See if you can determine what transformation, there might be more than one, could have occurred to transform triangle ABC into triangle DEF. To me, it looks like triangle ABC was rotated 90 degrees, but to the right, so that is clockwise, to get triangle DEF. So let's go from there and turn the page. The next question is, I want to identify two pairs of corresponding angles and the corresponding included side of those two angles, and we're going to use those to see if these two triangles are congruent. So, looking back, I'm going to use angle A. So I know that angle A, if we were rotated 90 degrees, corresponds to angle D. So let's write that down. So angle A corresponds to angle D. Then I'm going to use, I'm also going to use angle B, but so that means that the side that's included between angle A and angle B is segment AB. So the side that corresponds to AB then would be DE. So we would say side AB corresponds to side DE. So we have an angle, we have the included side, and then we already determined that angle B corresponds to angle E. Okay, so I have an angle, and in the middle of those I have the side that falls between those two angles. So what we're going to do is we are going to use angle-side-angle to prove that if these two triangles are congruent or not. So let's start with the first angles. So we need to find the measurement of angle A and the measurement of angle D. So use your protractors right now and see if you can determine and compare with the people in your groups the measure of angle A and its corresponding angle D. Okay, so to find the measure of angle A, this is very, very small, so we're going to have to use our best judgment here. So I'm lining up with angle A, and it looks like the line is going out to 20 degrees. So I'm going to say angle A is 20 degrees, and then I'm going to do the same thing for angle D. And it also looks like angle D is going out to 20 degrees. So I'm going to write that. Angle A equals 20 degrees. Angle D equals 20 degrees. So far, we're good. So then we need to find the length of the included side. So that's going to be side AB and side DE. Now for both of those, we're going to end up using the distance formula. So let's find the endpoints of AB and DE. Point A goes to the left, 2, 4, and then in between, so 5. And then it goes up 2, 4, 6, 8, 10. So angle A is at -5, positive 10. And point B is at -14, positive 2. So the point segment AB is at -5, positive 10, and -14, positive 2. So I'm going to plug those in. So the distance formula is the x's first. So that was -5 and -14. So I'm going to do -5 minus -14 squared plus. Since I use -5 first, I need to use positive 10 first. So that's going to be 10 minus 2 squared. And then I'm going to complete the distance formula on that. And then let's set up segment DE also, and then we'll do the distance formula on both of those. So DE point D is at positive 10, and then it goes up 2, 4, 5, and point E is at positive 2, positive 14. So I'm going to do 10 minus 2 and 5 minus 14. So the x's are going to be 10 minus 2 squared plus 5 minus 14 squared. And then I want you guys to finish the distance formula for both of those. So you might want to pause the video and finish that, and then you can check your answer with me. So when I have -5 minus -14, everything becomes positive. So that becomes -5 plus 14, which is 9 squared, plus 10 minus 2 is 8 squared. 9 squared is 81. 8 squared is 64. So that gives me the square root of 145 for AB. For DE, I get 10 minus 2, which is 8 squared, plus 5 minus 14 gives me -9 squared. 8 squared gives me 64. -9 squared still gives me positive 81. So the length of side DE is also 145. So far I have my corresponding angle, my corresponding included side, and then I need angle to find angle B and angle E. So use your protractors to find those. Angle B, it looks like, is also pretty narrow. If I use my best estimate, it looks like it's going to 30 degrees. And then we need to do the same thing for angle E, which looks like it is also going to 30 degrees. So angle B is 30 degrees, and angle E is also 30 degrees. So we have angle A and angle D congruent, AB and DE congruent, and angle B and angle E congruent. So we can say that triangle ABC is congruent to triangle DEF by angle, side, angle. And we proved that using the measurements. So let's look at what this means again in terms of the picture. So in my picture, I found that angle A, this angle right here, is congruent to angle D. Then I found that segment AB is congruent to segment DE, and angle B is congruent to angle E. So I had to have two angles and the side that's between them congruent to the two angles and the side that's in between them. And that's what angle, side, angle means. So you must have two angles and the included side congruent in order for the two triangles to be congruent using angle, side, angle. So your homework for tonight is going to be the skills practice for 13.5. So you guys have the rest of the period to start working on that.